I believe a major crisis took place in the late 1700s. Christians in Europe knowledgeable of the geological record simply could not conceive at that point in time how the Genesis flood could possibly have produced so much geological change in such a brief event as the flood. And their failure to defend Genesis 6 through 8 as the explanation for the fossil-bearing sediment record opened the door to naturalism on a grand scale. Well, it just so happens in the providence of God that technology developed to detect submarines during World War II provided a crucial piece of the puzzle, previously unknown. And during the 1950s, maps of the seafloor began to become available. And it was breathtaking. The results were breathtaking. Discoveries, things that people never even suspected, suddenly appeared on the scene. In particular, what is known as the mid-ocean ridge system became known for the very first time. And notice this highly symmetrical mid-Atlantic ridge. This ridge is part of a chain of high topography, some 40,000 miles long, running like a baseball seam through all the world's ocean basins. So immediately, Earth scientists began to puzzle as to what could possibly be the explanation for this feature, this major feature of the Earth's surface. And one of the most immediate issues was the age of this feature, the age of the rocks that are exposed on the ocean floor, especially the igneous rocks, but also the sediments. And an astonishing discovery was made, namely the young age of today's seafloor. All of today's igneous seafloor basement rock has been formed since the first appearance of dinosaur fossils in the strata record on the continents. In other words, the world's ocean floors are younger than a large fraction of the sedimentary record on the continents. So, what are some of the methods that were employed to come to this conclusion? One way of getting a relative age of rock in the ocean relative to the continents were fossil correlations between ocean bottom sediments and continental shelf sediments. The same types of marine, generally small marine animals that have very distinctive shells, many of which only appear once, only in a brief time period in the past, make these correlations possible. So it was found that the age of the sediment on the ocean floor correlated to recent sediments on the continental shelves. In addition, there was a magnetic reversal pattern that was discovered. And this pattern occurs in lavas, volcanic lavas on the continents. It occurs as magnetic minerals settle out of solution and appear in these sediment cores. Their alignments, their magnetic alignments can be measured, and one sees a magnetic reversal pattern in the sediment cores, and also in the basaltic basement rocks of the ocean floor. These magnetic directions are recorded. And these correlations also indicate that the ocean floor is young relative to the continental sediments. And finally, there were rocks dredged from the ocean floor, and the radioisotope values from this basaltic basement rock could be compared with continental basalts. And again, it confirmed this young age for the ocean. So this discovery that the ocean floor was young precipitated a paradigm shift in the earth sciences in the 1960s, a major paradigm shift. So how does this discovery affect our understanding of the flood? Well, it implies that all of today's seafloor has been formed since roughly the midway point of the Genesis flood cataclysm. If the flood is responsible for the fossils in the sediments on the continents, and the seafloor is younger than a good fraction of those sediments, it means that all this seafloor has come into existence, has been formed since sometime in the middle of the flood. The logic is just that tight and strong. And so this implies that thousands of miles of continental motion had to have occurred during the flood. It implies that none of the pre-flood ocean floor remains at the Earth's surface today. In other words, all the ocean floor that existed before the flood is missing from the Earth's surface. And these implications suggest the Genesis flood was primarily a tectonic catastrophe involving large-scale motions of rock inside the Earth. So many Christians haven't really thought much about the mechanism of the flood. Many of them, about the last teaching they had on this subject was when they were 4 years old in Sunday school, and they learned the song about the rains coming down and the floods coming up. Well, that's fine as far as it went, but what this data is telling us is that there was a lot more to the Genesis flood than simply rain from above and rising waters from below. So let me at this point give just a quick tutorial on the large-scale structure of the Earth. With this same map I've shown before, let me focus on a number of features. One, that the continents represent a layer of buoyant granitic crust with a density of about 15% less than the rock beneath it, and also the rock that makes up the ocean floor, about 20 miles in thickness of this lighter rock. And the ocean basins do not have that granitic layer. So that makes these continents buoyant. They float, if you want to think of it this way, like giant icebergs in the heavier rock. It makes them unsinkable, basically, this light layer of rock on top. These mid-ocean ridges, it was quickly realized, represent where two plates are pulling apart and new ocean floor is being formed as hot material rises to fill the gap. And then what are known as deep ocean trenches, for example, that exist, for example, off the coast of South America and Central America, is where ocean plates are plunging into the earth, back into the earth. So just noting those features, this is a close-up picture of what a spreading ridge looks like today, where these plates are, in today's world, are moving apart very slowly, like an inch or two per year. And we have material from below that rises to fill the gap, and all this rock is cooled by circulating ocean water in the cracks as this rock cools. And so very little magma actually reaches the surface, but it does rise up and fill the gap between these spreading plates. And this is a close-up depiction of what it looks like at an ocean trench, where this cold layer of ocean plate is plunging back into the earth, carrying down a little bit of sediment. Most of the sediment is scraped off at the top, but a little bit of sediment is left on the plate along with some water. That water causes the material to have a lower melting point, so when it gets down to sufficient depth, there's a great deal of melting, and we get volcanoes, commonly. So the ring of fire around the Pacific corresponds to where you see the melting occurring here. Now that's today's world, and what I want to look at as a mechanism I believe is responsible for the flood can be described by the term catastrophic plate tectonics. And in this case, these ocean plates sink very quickly, actually run away as a result of an instability that can occur inside the deeper earth known as the mantle. And when this runaway takes place, the surface is pulled down dramatically by kilometers. So this region where the plate is bending is pulled down by many kilometers, and this process, and as well as the continent, adjacent continent, is also pulled down and flooded. So we have some, when this happens a million times faster or more than it is today, some dramatic things take place. And then at a mid-ocean ridge, instead of it being really a ridge, you have a deep valley as these plates are pulled apart rapidly, and violent steam jets emerge from this deep valley as this hot rock is rapidly filling the gap. So catastrophic plate tectonics basically relies on the fact that ocean plates can sink because they are cooler and therefore denser than the mantle rock below. This 2,000 thick layer of rock below the plates is known as the mantle. It's almost everywhere solid, not liquid like a lot of people have been led to think. It's solid rock. And below that is the core, which is molten for the most part, a small solid inner core we know from seismology. So you can basically divide the Earth into two main parts, a rocky upper part, about 2,000 miles thick, and then a mostly iron, mostly liquid inner, core. Anyway, the picture is that for this catastrophe, that the ocean plates sink rapidly on the order of meters per second into the mantle. So before I go into some numerical modeling of this process, I want to just quickly summarize some of the consequences of an episode of catastrophic plate tectonics. One of the first things that happens is the cold ocean floor sinks into the mantle. It tends to drag the continents downward. It's replaced by hot new seafloor with hotter material rising from below. This hotter material has a lower density. It rides up higher than the old seafloor. It shallows the ocean basins, raising the world's sea level and flooding the continents. So we have molten magma rising to fill the gaps where the ocean floor is pulling apart and is sliding like giant conveyor belts into the Earth's interior. Steam generated from the hot rock at these ridges erupts as violent supersonic jets, jets like this, where we have water circulating down through the hot rock, becoming supercritical. There's a supersonic shock, supersonic velocities in these jets. Some of that high velocity steam entrains liquid water as it rapidly penetrates the layer of ocean water, and that water comes down as heavy rain. And this solves a major problem for creationists in the past of how we could condense so much rain. Here, there's no need to condense the water. It just falls down it never goes to a vapor phase. It falls to the earth as liquid water. As these ocean plates plunge into the earth at the continent margin, sediment from the pre-flood ocean bottom is scraped away and accumulates at the continent edges, provides a major source of sediment. As the hot rock from the base of the mantle rises and spreads rapidly beneath the ocean plates, the volume of the ocean basins is greatly diminished and the global sea level rises dramatically, as I've already indicated. Intense water currents in the form of giant eddies and driven by the Earth's rotation arise over the flooded continental areas as the global sea level rises. I reported this at the 1994 International Conference on Creationism, a chance discovery I made that these high velocity currents arise spontaneously, able to transport vast amounts of sediment, and they have great erosion capability, and so have velocities more than 100 miles an hour in these large-scale currents. So that's able to erode and transport large amounts of sediment and deposit it and form laterally extensive sediment sequences. So those thick sediment sequences are spread out in blanket-like manner over the emerged regions of continent to produce this layer cake pattern of sediments over the continents. And of course, most living organisms perish in such a catastrophe. Some are preserved as fossils, like these dinosaur bones. And thus we have a record of this catastrophe as these floodwaters encroach onto the continents at higher and higher topographic levels in the continents, destroying successive ecological regions on the continents. The flow of rock in the mantle, driven by the sinking seafloor slabs, moves the continents apart by thousands of miles and opens the Atlantic and Indian Oceans. So we have, for the most part, North and South America moving westward relative to Europe and Asia and opening the Atlantic Ocean and forming this mid-ocean ridge where the seafloor is spreading apart. Now, all of this is driven by the gravitational potential energy of these heavy seafloor slabs that have this natural tendency to sink. However, when they reach the bottom of the mantle, and when the hot rock at the bottom of the mantle reaches the top, this potential energy is mostly exhausted. And when this happens, the runaway episode ends. The velocities and stresses diminish, extreme surface deformations relax, and the global sea level begins to fall. And I'm going to show a calculation in a moment, an animation, where after this, it shows this runaway mechanism, and after the cold material spreads out over the bottom, the hot material spreads out beneath the surface, the velocities fall very rapidly towards zero. So after this, the water rushes from the continents, erodes and reworks much previously deposited sediment. Much of the sediment you see on the left-hand side of this figure was also on the right-hand side of the figure and has since been eroded away. And almost certainly it was eroded away in the runoff stage of the flood. Massive runoff from the continents. And another feature, another aspect of what happened after the flood, the zones of thickened low-density crust, mostly the result of subduction at a continent edge. These thickened zones bob up like cork because of their buoyancy to generate the present-day high mountain ranges. So whereas during this runaway catastrophe, this continent edge was underwater, when the driving forces become close to zero, this region where the low-density crust has been thickened bobs up to equilibrium, and a result is a high mountain range, like the Andes, the Alps, the Himalayas, the Rockies. Another result was the warm oceans after the flood lead to vigorous atmospheric circulation, increased moisture carried to high latitudes, and formation of massive ice sheets near the poles. And this map shows the greatest extent of the ice sheets in northeastern Asia, Europe, and North America that would logically follow as a result of the flood catastrophe and the oceans getting warm during the flood. So if this type of cataclysm really happened, how does one approach the study of such a one-time event? Well, generally speaking today, about the only way to study it seriously is by computer modeling. And so I realized this, and so for my PhD research, my PhD thesis, I developed a numerical model for the mantle. And this is the grid that I used. The model is now known as Terra. And basically the idea is to chop the mantle up into lots of small cells and then simply solve conservation equations, conservation of mass, conservation of energy, conservation of momentum, or for this case, it just corresponds to a balance of forces on each one of these little cells. And it takes a large computer to do that, but in principle, it's straightforward to do that kind of calculation. And this slide just shows how that grid is generated from a figure known as the icosahedron. And for any engineers in here, just to give you a little hint as to the type of code it is, it's a finite element formulation. I just showed the kind of spherical mesh that I use. It's that mesh is naturally suited to be divided up into blocks, 10 logical blocks, and is nicely suited to work on a parallel computer. And it has a lot of physics put into it. It can handle compressibility, spatially varying material properties, real equations of state, and lithospheric plates, and many other things. So I had the privilege of supervising several graduate students during the 90s, and one of the graduate students, this was part of his PhD research using Terra, and he later got a position at Princeton and is now a full professor at the University of Munich. So this code has been used by many research groups around the world. And let's first look at this question of how can rock sink through 2,000 miles of rock within just a few weeks' time? That's an absolutely essential question if this model is to have any viability at all. So it's possible because silicate minerals, it has been shown, weaken dramatically by factors of 1 billion or more when they're under stress. And these experiments have been done in many laboratories for the last 30 years around the world. This is an apparatus that has been used, oven. The sample is placed in the middle of this cylinder you see, and force is applied to it from the rods going in the top and the bottom, and everything is controlled very carefully, the amount of stress applied, the temperature, and from the rate of deformation of the crystals, one can back out their mechanical properties. One can also look at them after the experiment, look at the style of deformation, and this is a photograph, in effect, from an electron microscope showing how planes of atoms have slid over one another. And this kind of deformation is known as dislocation creep. Very well studied, and so well studied they're able to generate maps like this, a map of deformation rate versus stress versus temperature. And it shows that this mineral olivine can deform by the rate of deformation can change by a factor of 1 billion with relatively modest changes in stress. And so what I've done in this next calculation I'm going to show is put that, represent that plot that I just showed you in equation form, put it into a calculation, and this is simply a 2D calculation where I can apply lots of computer power to it, make the cells very small, and can track the runaway instability that unfolds. The top panel is temperature, where red is hot and blue is cold. The arrows denote velocities, and the bottom panel is the rock strength, where blue is weak and red is strong. And this dark blue color represents a strength 1 billion times smaller than what the rock would have if it was not under stress. So we're partway in a runaway regime here, where these red blobs, these red plumes, have suddenly started rising at a high rate of speed, rising toward the surface. So this is after 5 days into this calculation, after this runaway begins. So they come roaring up to the surface and cause the top surface, the blue region, which is cold, then to run away. So this is after 12 and a half days. The hot plumes are near the top. The cold material has started to run away, plunging to the bottom. Most of the region, as you see in the bottom panel, is blue, has become very weak. And so this whole volume has become weak and moving very rapidly. The height of the box is about 2,000 miles. So it corresponds, I've chosen the parameters in this calculation to represent the Earth's mantle. And the velocity, denoted by U max there in this panel, is like 5.5 meters per second. That's many miles per hour. I think that's about 10 to 15 miles per hour this material is sinking. And this is at 20 days. Material's slowing down. Velocity is only at 2.3 meters per second here, and it rapidly decreases, and the bottom panel in subsequent times becomes red, and so the thing comes to a relatively rapid halt after the gravitational potential energy driving this process is exhausted. So this is the animation here, and I loop the animation several times to give you an idea. But this shows this is an actual numerical simulation of this runaway process using actual data from laboratory experiments for the deformation characteristics of the rock. So and this represents some very sophisticated numerical methods to be able to track this physical instability. And a few of my colleagues have come up with the ability to do similar work and have validated this calculation. So now I'd like to show you a few results from my 3D model. And basically what the calculation I want to show you, I've taken a representation of Pangea, a reconstruction, an estimate of where the plates were at this point in geologic history. This is, of course, in the evolutionary time scale, and it would occur, this distribution would have existed in the flood, at a time during the flood. I take that, roughly that present-day continents, move them back to their Pangean positions, put coal material around most of the boundary of this supercontinent, the blue that you see there. That blue material is 400 degrees cooler than everything else, extends down about 400 kilometers into the mantle. This is a slice through the equator. The white area in the middle corresponds to the core. I'm not including the core in the calculation. And I use this initial condition, this initial distribution of coal material, to start the motion, to start the calculation going, and I simply solve the conservation equations in the computer, allowing this system to develop as it wants to. And so this is the result at the surface after 15 days' time. And we see the blocks, these continental blocks, pulling apart, primarily driven by this coal sinking material. And I have plate boundaries in the ocean areas where there's evidence that they also existed. And we have these ocean plates pulling apart along those boundaries. So that's the surface. That's a view at 65 kilometers depth. This is the slice through the equator. We see the coal material sinking, and it thickens. Those blobs get thicker because I've put in a higher strength in the lower part of this mantle, as various lines of evidence indicate. And so this is at 25 days, and there's been a lot of motion. We have velocities at the surface on the order of 3.5 meters per second. The blocks are moving roughly in the right directions. This is a cross-sectional view, the coal material sinking down toward the bottom, eventually spreading over the bottom, and the process coming to a halt. This is a view from the North Pole, at that same time a view from the South Pole. So it gives you a flavor of what unfolded during this catastrophe. Now, do we have any observations supporting a recent episode of catastrophic plate tectonics? Well, a field of study that's unfolded in the last 20 years is known as seismic tomography, using thousands or tens of thousands of earthquakes to develop a 3D picture of the inside of the mantle. And this is one of these reconstructions of the structure of the mantle. And what's a feature of almost all these models is that there's a ring of coal material that borders the margins of the Pacific Ocean. And then, and so we see the Pacific side, and there's a blob of red material, hot material, squeezed up like toothpaste in the middle of this ring. This same ring can be seen from the eastern hemisphere, where we're basically looking at the African continent. And again, a blob of hot material, low-density material squeezed up in the middle. And a big dilemma for modern geoscience is why this coal material has such a large density contrast. If it took 100 million years, as the standard evolutionary framework requires, that material should have mostly warmed up. It should not be as cold as it is. But if it only has been down there a few thousand years, it's understandable why it has the big density contrast. So the density contrast of this ring is evidence of a recent episode of catastrophic plate tectonics. Furthermore, a similar catastrophe, a runaway catastrophe, appears to have taken place on Venus in the recent past. And this data is from the Magellan mission in the early 1990s, which indicated the planet had been catastrophically resurfaced via processes inside the planet. And much of the planet has been just flooded with hundreds of meters of basaltic lava, as we see here. These bright features are cracks that formed when this basaltic lava cooled. But this lava obliterated any craters that had existed prior to this catastrophe. So there's a good fraction of the surface of Venus is featureless, like you see here. There are a few impact craters, like we see in this photo, but the ejecta blanket is pristine, no evidence of any erosion or degradation of the ejecta. It's as if these impacts occurred just yesterday. And this led most interpreters of the data to conclude that Venus had been catastrophically resurfaced in the recent past. This is another image of three nearby craters, probably a single object that broke up as it went through the dense Venus atmosphere. I'd like to close here with this quote from Martin Luther, who said, "If I profess with the loudest voice and clearest exposition every portion of the truth of God, except precisely that little point which the world and the devil are at that moment attacking, I am not confessing Christ, however boldly I may be professing Christ. Wherever the battle rages, there the loyalty of the soldier is proved, and to be steady on all the battlefield besides is mere flight and disgrace if he flinches at that one point where the devil is attacking." Well, I say the devil has been attacking ferociously with uniformitarianism. And for the most part, the church has been slow in responding. And the urgency is no less today than it has been for the last 150 to 200 years. The battle is still raging intensely on these issues. In 2 Corinthians 10, Paul says, "For the weapons of our warfare are not of the flesh, but divinely powerful for the destruction of fortresses, destroying speculations and every lofty thing raised up against the knowledge of God, and taking every thought captive to the obedience of Christ." And I pray that all of us will come away from this conference with a renewed vision, a renewed commitment to having a part in this enterprise. So thank you for your attention.